Hello, now we're going to be looking at using your calculator to find probabilities on a standard rather than using the standard normal table. Now, there's one main function that we'll use in our calculator, it's normal CDF. The newer calculators, you don't need this notation, but the older calculators you do. Calculators, I should say. Normal CDF, you type in your min, comma, your max, if it's standardized, meaning you have z-scores. If it's not standardized, after you do min max, then you type in your mean and standard deviation. For instance, let's do an example. Consider babies born in the normal range from 37 to 43 weeks of gestation. They've seen that their weights are normally distributed with a mean of 3,432 and a standard deviation of 482. So we want to find, first off, the probability that the weight is less than 4,000 grams. And just like what we did before, we'll do that the probability of x being less than 4,000. Then we try to find the z-score, and we find our z-score. Now we have to find the probability. So instead of running to our tables, what we can do is we can take out our calculator, and we want to do normal CDF, which you hit second, and you hit vars, which brings up the distribution menu. Normal CDF is number 2. Now our normal CDF, we're using a standard normal, so the mean is 0, standard deviation is 1, and we're going to go from, we want to, if it's less than 4,000. So in our normal curve, if I drew this out to the right, we're going to start at 1.78 here and go all the way to the left, something like that. So on the left-hand side, our x minimum is negative infinity, but on the right-hand side, we want to stop once we get to 1.178. So that's what we're going to do here. Our lower bound is negative infinity. So we can't type in infinity, but we can type in negative 999. And then we want to go all the way up to our z-score of 1.178. And once we have that, we hit enter, and you find that our value is 0.88. So 88% of the data, and you can see that from our diagram, looks like about a good chunk of the data is in that range. So let's try something else. What's the probability that a randomly chosen baby of this type is more than 3,000 grams? We started the same way. We're going to find the probability that our x value is above 3,000. And then we'd find the z-score of that. We subtract the mean divided by the standard deviation. Once we have that, we get a z-score of negative 0.8963. Now we take out our calculator. Since this is greater than, I'll try to make a drawing. So greater than 0.8963. Our standard normal, that's 0. That would be negative 1. 8963 is going to be about there, and it's going to go to the right. Now you can make estimates just by a quick little drawing like this. You know it's above 50%, not quite 84, so maybe 70 some percent, or below 80, something like that. Now we're going to start at negative 0.8963, and we're going to go to the right forever. So I'm going to do my normal CDF by hitting second vars, normal CDF, and now we're going to start at negative 0.8963, and we're going to go to infinity, which 999 is close enough in this instance. And then when I hit enter, I got 81, or about 81.5%. So about 81.5% of the values are greater than 3,000. Now, if the value is between 3,000 and 4,000, we do everything we did last chapter, or last section. It's between 3 and 4,000. We find the z-scores for each of them. Once we have those z-scores, then we compute them to be 0.8963 and 1.78. So now we take out our calculator, we do our normal CDF, and now our lower bound is 0.8963, but now our upper bound is 1.178. And we still have a mean of 0 and a standard deviation of 1. And now when we do that, we have a value of 0.6956. All right, so now if we want to find this between 2,500 and 3,500, the first thing we got to do is see is between 2,500 and 3,500. Then we find our z-scores for both of them. Now that we have the z-scores, we compute them. And now we take out our calculator and we hit second bars, number 2. We're going from negative 1.93 all the way up to 0.14. And once we have these, we paste it, and it's about 52.88%, 52.89. Now hopefully that's enough to do your on your own. Goodbye.